General relativity, step by step. I've got this nice expression here for the second derivative with respect to proper time tau of n, which is the separation vector between separation 4 vector between two particles following geodesics. But I've not really used any physics here. What I need to do is to use the the equation goes on, doesn't it? I think that's there's the last bit there. What I need to do is to use my geodesic equation, which was some considerable way back. Oh, well, I've got it here. I had to mark it with these green stars. So you'll remember that this equation here was derived from the fact that both particles were following geodesics. So I've got that here, and I think I need this form here, which I'll copy down underneath here, which is here. So what I've got here, the original geodesic equation with the green stars was d2n alpha by di tau squared plus 2 Christoffel alpha mu nu u mu dn nu by d tau plus n sigma di Christoffel alpha mu nu by di x sigma u mu u nu. So alpha's free. Actually, what I'll do is I'll get rid of alpha everywhere it occurs and just shade it in red just to check. So there's an alpha there, and an alpha there. That's right. And the sigma is summed, the mu is summed, and the nu is summed everywhere they occur. Okay, so now my task is to use this equation in this one here. So basically, oh, that equals 0. Oops. Go back to black. And that equals 0. So I've got a nice expression here for this, and I'm going to substitute this expression into that term there. Good grief, let's do this then. d2n vector by d tau squared alpha equals minus, because this thing equals 0, and so that's gone to the other side, 2 Christoffel alpha mu nu u, which is the full velocity of your particle, mu dn nu by d tau minus n sigma di Christoffel mu nu di x sigma, copying from here, u mu u nu. That's that term there which I've done, substituting from the geodesic equation here, plus 2, copying from here, dn sigma by d tau u mu Christoffel alpha mu sigma, plus this term here, n sigma du mu by d tau Christoffel alpha mu sigma, plus this term here, n sigma u mu u nu di Christoffel alpha mu sigma by di x nu, that term there, plus the final term, which is this one here, Christoffel alpha sigma nu u sigma, good grief, it's not easy, is it, beta gamma u beta. You get similar problems in algebra when you work with hypergeometric functions. You get very similarly naturally occurring but algebraically horrible expressions. Hypergeometric functions are very unsuitable and for human beings to think about. They're not nice and clean and crisp. It's the same as this thing. They're correct, the equations are right, but they're just not nice. Okay, let's just have a look at this equation here. We've got this term here, we've got dn by d tau, we've got that, we've got this, we've got another dn by d tau, du by d tau here, which I need to simplify. And I think that's the only du by d tau we've got. Okay, so we need to substitute for d, and I'm going to use the equation du mu by d tau equals d2x mu by, I'll just write that a bit more neatly, d2x mu by d tau squared. So I'm going to substitute that. This is true by definition because it's d by d tau of dx mu by d tau. So it's true by definition. Right, so I'm going to substitute that for that and then we'll see what happens. Stop.